Today we're going to be taking a look at changing binary numbers into a hexadecimal format and changing the hexadecimal format back into binary numbers. So let's talk about what hexadecimal actually means real quick. Well, hexa is a prefix meaning 6. Deci in the word decimal means 10. So we can use 16 different characters for each group of 4 bits that we have. Now, we use the numbers 0 to 9, which is the first 10 characters, and the letters A to F, which are the last 6. Now, you might be saying, why would you use letters? Well, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Now, you might be saying, we just talked about using 16. Why do you stop at F? Don't forget that 0 is a number 2. Now, we can't use 10 because it would read 1 0 with one bit represented by the 1 and another bit representing a 0. You cannot do that, but we can use letters to represent those numbers greater than 9 in the hexadecimal system. So binary to hexadecimal. A hexadecimal number is composed of a minimum of 4 bits. 2 hexadecimal numbers would be 8 bits or 1 byte. 3 hexadecimal numbers is going to be 12 bits or 1.5 bytes. So it's going to be in factors of 4 or multiples of 4. Now each binary digit, the 1 or 0, takes up 1 bit. So let's take a look at this binary number here. We have 0100110, and that's the number 38 if we change it into a decimal ordinary number. And how many bits are there? Well, if we take a look at this number, we see there are 1, 2, 3, 4, 5, 6, 7. So we know this is going to have at least one hexadecimal number because I have more than 4 bits, but I only have 7, not 8. Well, if a hexadecimal number is composed of a minimum of 4 bits, how do I change this into hexadecimal if there's only 7 and not 8? Well, it's very simple. All you have to do is throw in a 0 in front of the number until you have the minimum number of bits. We need one additional 0. Now, this is common practice, and it is correct to do. So our new binary number is going to be 001001110, which is still 38. How many bits do we have now? We have 8, which means we can start the conversion, and we are ready to go. So we take our hexadecimal or our binary number that we just looked at, and we look at changing it to hexadecimal. Now, there's a simple series of steps to follow, and if you follow these steps, you'll get it right every single time. So we read the group of 4 bits, and we group them from left to right. Now, we have 8 bits total, which means we are going to have 2 hexadecimal digits because each hexadecimal digit, remember, takes up a minimum of 4 bits. Your teacher may call it a nibble. A nibble is 4 bits. Now, so we group them from left to right. So I take my first 4 bits here, 0010, and I'm going to group it. Then I take my last 4 digits, 0110, and I group them right over here, the last 4 bits. So I have them grouped, and I'm ready to go to the next step. So my first set of 4 bits is 0010, 4 bits, 1 hexadecimal digit. My second set of 4 bits, 0110, I have 4 bits, 1 hexadecimal digit. Now we convert 0010, my first group right here, to denary, and then my second group to denary, and we do these separately. You can't just say, okay, well, I know this is 38, so this is going to be a 3 and an 8. You can't do it that way. So we convert them and we do it separately. So I take 0010 and I put it into binary. I'm going to get 0 plus 0 plus 2 to the power of 1 plus 0, which is going to be 2. And the 2 that I'm getting comes from 2 to the power of 1, which is represented by this 1 here. I take my second set of bits, which is 0110. I'm going to get 0 plus 2 to the power of 2 plus 2 to the power of 1 plus 0, which equals 6. The 6 comes from adding these 2 numbers right here. Now, if you don't know where we're getting these 2 to the power of 1, 2 to the power of 2 from, you need to go back and look at how binary numbers work. If you do not understand how binary numbers work, you're going to have a heck of a time, if at all, understanding hexadecimal numbers. So now that we have this, we can work it out. So we code for the 2 digits, the 2 and the 6. Anything 9 or less is the number given. So we know the first digit is going to be 2 because 2 is less than or equal to 9. What about the second digit? Well, 6 is less than or equal to 9, so our next digit is going to be 6. So if I'm coding this binary number right here in the hexadecimal, it's going to be 26. And so if someone said, hey, we need to change 38 to hexadecimal, it's going to be 26. It's that simple. Let's take a look at another example where we don't have 2 numbers, but where we use letters as well. So binary to hexadecimal. So let's take a look at this number here. We have 10001010 to hexadecimal. We read the group of 4 bits and group them from left to right, just like we did in the last exercise. And we have 8 bits, which means we're going to have 2 hexadecimal digits. So I group them here, 1000 into the first group and 1010 into the second group. Now, when I change 1000 into binary, I get 8, which comes from 2 to the power of 3. So I know my first hexadecimal digit is going to be 8 because 8 is less than or equal to 9. When I work out 1010 and change that into a denary number, it comes out to 10, which is from 2 to the power of 3 plus 2 to the power of 1. That's going to be 10. Well, I can't use 10. I got to use a letter. So we can only use one hexadecimal digit for 10. When going beyond 9, remember we switch letters all the way to F, with A being 10, 11 being B, 12 being C, and so on. So our hexadecimal number here is going to be 8A, because in my first group, I get the number 8. In the second group, I get the number 10, which is represented by A. So my hexadecimal number for this binary number is going to be 8A. Well, let's talk about changing hexadecimal to binary. It's very simple. Each hexadecimal digit, remember, it's going to be separated into 4 bits, with each bit being comprised of a 1 or a 0. So let's take 4F. We're going to separate it like so. We're going to take 4, and we're going to have 4 blanks here. In each blank, we're either going to have a 1 or a 0. So I have 1, 2, 3, 4 bits here, 4 blanks with a 1 or a 0, because remember, binary numbers use 1 or 0. And then I have the letter F, and I'm going to have 4 blanks here as well. 1, 2, 3, 4. We're good to go. Now, we know that 4 is the number 4, so my binary numbers here need to represent 4. And we know that F is going to be 15, so I need these binary numbers to represent 15, and then we'll be ready to go. Now, remember, if a number is greater than 9, you have to switch the letters. A is 10, B is 11, C is 12, and we go all the way to F, which is 15. And F is the last letter that we can use. Because hexadecimal, we can only use 16 characters. 0 to 9 and A to F. Because remember, 0 is a number 2, and that's why F is the last one we can go to. So we have it separated here. I got my little binary table set up. 2 to the power of 0, which is 1. 2 to the power of 1, which is 2, 2 to the power of 2, which is 4, 2 to the power of 3, which is 8. I have both tables set up here. And I only go 2 to the power of 3 because I only have a maximum of 4 bits. So how do I change 4 into a binary number that will give me 4? Well, that's very easy. I know I don't need 8, so I'm going to put a 0 there. 2 to the power of 2 will give me 4, so I'm going to put a 1 there. Well, if I have 4, which is what I need, I know these two are going to be 0. So my first group of binary digits are going to be 0, 1, 0, 0. Now F, I know F is 15. What can I do with these numbers to get 15? Well, 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 1 is 15. So I'm going to make these all 1s. And my second set of binary digits are going to be 1, 1, 1, 1. So my binary number, I look up here for the first 4 digits, 0, 1, 0, 0, which I have right here. And then my second set of binary digits, which are 1, 1, 1, 1. And that is how you change hexadecimal to binary. If you follow this system every single time, you'll get it correct. I guarantee it. Work it nice and slow and double check yourself. Always double check yourself, because making one small, simple mistake will lead to a disaster, and you'll get it wrong. So make sure you slow down, check yourself. If you have any questions, you can always comment or email me, and we'll see you guys next time.